Today we will learn gas laser and specifically carbon dioxide gas laser. It is also termed as molecular gas laser since CO2 is in the gas is in the form of molecules here. Gas laser have many types. Helium neon laser is an atomic laser whereas CO2 is a molecular. In this syllabus we have CO2 and N2 laser. We will be able to learn principle, construction and working and also the application, many applications of CO2 laser today. As in the previous lecture we have discussed types of laser on the basis of material used. Gas laser is a laser in which electric current is discharged through a gas, which is done inside a laser medium to produce laser light. In gas laser, the laser medium is in the gaseous state. Gas laser is the first laser that work on the principle of converting electrical energy into light energy. And that is why it also have very important. Efficiency of the gas laser is also very nice, excellent as compared to others. As the gas laser have very special characteristics, is used in application that require laser light with high beam quality and long coherence length. In gas laser, the laser medium or GaN medium is made up of mixture of gases. We pack this mixture in a glass tube and the glass tube filled with the mixture is called active medium or laser medium. In this mixture, those atoms or molecules which are responsible for lasing action directly called active center. Many lasers are there, for example helium neon laser, argon ion laser, carbon dioxide laser, carbon monoxide laser, excimer laser, nitrogen laser, hydrogen and so on. Out of them two are very famous, helium neon laser and CO2 laser. Helium neon laser is an example of atomic laser as helium and neon both are in atomic phase, whereas CO2 is a molecular laser where all the mixture is in molecule phase. In the case of helium neon, helium works as active medium, so we kept large number of helium there, and then neon is an active center. As we have discussed, there are many types of gas laser. CO2 laser, this laser can emit hundreds of kilowatts at 9.6 micrometer and 10.6 micrometer and often used in industries for cutting and welding tool. The efficiency of CO2 laser is over 10%. We also have other laser like carbon monoxide have potential for very large objects. But the use of this type of laser is limited by toxicity of carbon monoxide gas. Helium neon laser is another example. This can be made up of to oscillate over 160 different wavelengths by adjusting cavity Q to peak at the desired wavelength. Is a very special properties now we have developed. This is done by spectral response of mirror or by using dispersive element in the cavity. There is another type of laser that is called nitrogen laser. This operates at ultraviolet range in 337.1 nanometer. This is also a molecular laser. Transversely excited atmosphere laser, in short called TEA laser. This is energized by a high voltage electrical discharge in a gas and a mixture generally at or above pressure. So many things are there, but CO2 is one of the best gas laser we use. In a molecular gas laser, laser action is achieved by transition between vibration and rotational level of molecules. As we have discussed, in the case of atomic gas, the electronic transitions are possible. But when we have molecular gas, then for example CO2, CO2 have many covalent bonds with oxygen. Now, whenever you give energy, the energy will be utilized by molecule in rotation, vibrations, and these are the levels which is used for lasing action. Construction of this laser is simple and output of the laser is most of the time continuous because it is a four-level laser. Upper lasing action and lower lasing level both are there. We never use ground state as a lower lasing level. That is why it is called four level. The transition takes place between vibration states of carbon dioxide molecules. The CO2 carbon dioxide was one of the earliest gas laser developed. This was invented by Kumar Patel of Bell Labs in 1964 and is still one of the best useful laser. Carbon dioxide laser are the highest power continuous wave laser that are currently available. They are also quite efficient. The ratio of output power to pump power can be as large as 20%. The CO2 laser produce a beam of infrared light with the principal wavelength and bands entering on 9.4 to 10.6 micrometers. Yes, in this slide we have just consolidated characteristics of the laser. It is a molecular gas laser as CO2 is a molecule. We have discussed this. In this active medium, a mixture of carbon dioxide, nitrogen and helium or water vapor is used as active medium. Pumping method used is electrical discharge. We fill these gases, mixture gases in a discharge tube and we pump through electrical discharge. The optical resonator basically is a two concave mirror form a resonant cavity. The output from this laser is about 10 kilowatt. The nature of output is continuous and output is zero point 0.6 micron and 10.6 micron. Carbon dioxide laser has a carbon atom at the center with two oxygen atom attached, both sides. Such a molecule exhibits three independent modes of vibrations: symmetric stretching mode, in which the bond stretched, then bend, the bonds can break, bend, and asymmetric stretching mode. We will discuss these things in these slides. In this figure, we are trying to explain symmetric stretching mode. In this mode of vibration, carbon atoms are at rest and both oxygen atom vibrate simultaneously along the axis of molecule departing or approaching the fixed carbon atom. You are observing here this dashed line of oxygen and full circle, full circle and dash circle. This shows the stretching. If both symmetric means both go first in outer side and then both go to the inner side. If then this is called symmetry. In the mode of vibration, carbon atom are at rest and both oxygen atom vibrate simultaneously along the axis of molecule, departing or approaching the fixed atom. Then this is called symmetry. The second type of the vibration is bending mode, where the molecule bends. As you are observing here, it shifts from this position to this position and so on. If this will shift here, then this will shift in upward direction. This is called bending, and this is due to atom vibrate perpendicular to molecular axis. This also generates some levels in CO2 molecules. The third type is asymmetric vibrations, in which the oxygen and carbon atom vibrate asymmetrically. Asymmetrically means oxygen atom move in one direction. Suppose this oxygen atom move in outward direction, then this will move in inward direction. And similarly, it is moved inward direction, then this will move in outward direction. This is called asymmetric stretching. As this is here we have shown construction, we have added the mixture here. The mixture of hydrogen, and carbon dioxide from there. And here we have two mirrors, partially and fully polished. Now here we have applied a power supply and vacuum is created. On both sides we have used NaCl booster window. As we have discussed that CO2 laser, we use gas filled tube. In the end, we have mirrors, one of which is fully partial polished and one is partial polished. And gas mixture is fixed here. The dimension of this tube is about 5 centimeter long and 2.5 centimeter in the diameter. So it's a long tube of very small diameter. We have used very narrow tube so that the interaction between the molecule will increase, and here the energy transferred by one molecule to another, one gas to another. Here CO2 is an active medium and helium and nitrogen is suitable partial pressures. We added. The terminal of the discharge tube are connected to DC power supply. The end of the discharge tube are filled with NaCl windows so that the laser light generated will be polarized. Two mirrors, set of mirror is shown here, partially and fully polished. When an electric discharge occurs in the gas, the electrons collide with nitrogen molecules and they raise these nitrogen molecules to excited state. This is called absorption. Actually, as I told you, here we transfer the energy. First, we excite nitrogen and this nitrogen transfer this energy to CO2 and then we get laser action. When stimulated by electric current, nitrogen molecule in the gas mixture become excited and they gain energy. Why nitrogen gain first? Because first thing is we use nitrogen more in number. It can hold this excited state for a long period. That's why we have chosen this without discharging the energy in the form of photons. The high energy vibration of the nitrogen in turn excite the CO2 by through collision. As the tube is very narrow and we are having nitrogen and CO2, so nitrogen is more, first get the energy, then they transfer the energy. The condition is special here. Both have almost same excited level. Then only we can use this pair. So this is the particular pair. Now N2 transfer this energy to CO2. The high energy vibrations of nitrogen excite the CO2. At this point, the laser achieves a state called population inversion, the point at which system has more excited particle than non-excited. For the laser to produce a beam of light, the nitrogen atom lose their excited state by releasing energy. This happens when excited nitrogen atom contact very cold helium ions, which cause the nitrogen to release light. So we can also understand the role of helium here. Helium is used to cool the nitrogen to get to non-excited state, and nitrogen transfer energy to helium. Nitrogen excited state, first is ground state. We use N2 as ground state and N2 star as excited state. N2 star molecule in the excited state collide with CO2 and excite to higher level. This is shown here. Nitrogen is giving energy to CO2, and nitrogen broken to ground state, and CO2 become excited. Nitrogen molecule in excited state denoted by N2 star, and similarly CO2 denoted by C2 star. Since the basic condition, as I told in the previous slide, the basic condition for this, why we have chosen the excited level of the nitrogen is close to E5 level of CO2. That is why we have chosen this. So this transfer the energy and populate E5 by CO2 molecules. As soon as the population inversion condition achieved between E5 and E4, there are two types of lasing action possible from this metastabilized excited state. One is E5 to E4, and another is E5 to E3. E3 is another lower lasing level. When we have transfer from E5 to E4, we get 10.6 micrometer wavelength laser, and from E5 to E3 we get 9.6 micron. However, we must note this that 10.6 micrometer transition is more intense as compared to another one, 9.6. The output is about 10 kilowatt. Following are the advantages of the laser. The construction of CO2 laser is simple, output is continuous, it has very high efficiency, it has high output power. The output power is increased by extending length of the gas tube. However, there are certain disadvantages of this laser also. The contamination of oxygen by carbon monoxide have some effect on laser action. So it should be pure CO2. The operating temperature plays an important role in determining the output power. The corrosion may occur in reflecting plates, and the accidental exposure may damage our eyes since it is in invisible rays, invisible side. Sometimes it can't be visible to us. So these are the disadvantages and challenges. We have many applications in high power CO2 laser find in many material processing, welding, drilling, cutting. The low atmospheric attenuation laser suitable to open air communication. It is used for remote sensing. It is also used for treatment of liver and lung diseases. In medical purpose, we also use for surgery purpose and to perform microsurgery and bloodless question. Thank you and take care.